All right, so today's topic is quadratic functions, and we're going to go over the graphs of them. As you can see here, this is the parent function of a quadratic function, and it looks like a U. That's also called a parabola, P-A-R-A-B-O-L-A. That's a mathematical term for this shape. All right, so g of x equals x squared. That is going to be the parent function. And here I set up similar to what we do with the absolute value functions. We got some, just like we did with the a and h and the k, those numbers are going to change the shape of the graph or change the location of the graph. They're going to change or transform the graph in some way. All right, so let's see what they do. All right, so let's look at a first. All right, so that is going to be, A is going to change the graph the exact same way it changed for the absolute value functions. A is going to be a vertical stretch or compression, depending on what value it is. If A, let's see here, let me start. All right, if A is 1, there's no change. If it's greater than 1, as you see, that's a vertical stretch. The graph is getting skinnier. Okay, what if A is positive but less than 1? It gets fatter. It's a vertical compression. Okay. And then, of course, if A is negative, just like with the absolute value functions, it also reflects it. It's going to vertically stretch or compress and reflect, as you can see right there. Okay. So that's what the effect A has on the graph of the quadratic. Let's look at H and K. This is going to be exactly like the absolute value functions also. H is inside the parentheses. We are subtracting it. So it's going to be a horizontal translation when you change the value of H. H is also the coordinate, the x-coordinate of the vertex. As you can see here, H is 4. So inside the parentheses, we would have x minus 4 squared if I wrote that out. And the vertex is at 4 on the x-axis. Okay, so H is going to horizontally translate the graph. So then what is K going to do? It's going to vertically translate the graph the exact same way we did with the absolute value functions. So if K is -1, vertex is at -1. K is 2, the Y value of the vertex is +2. So if I did all of these changes to the graph here, this A, when A is 2, it's going to vertically stretch it by 2. It's going to be skinnier than the parent function. All right. H is 3, K is 2, so my vertex is 3, 2, just like that. All right. If I make these negatives, now my vertex is -5, -3. And look, there's the values of H and K, -5, -3. All right. So this is very, very similar to the absolute value functions, and that's about it. One topic I left out is the axis of symmetry. Let me reset all these. All right. The axis of symmetry is the vertical line that splits the graph in half. So for the parent function, it's x equals 0. Okay. But let's say I move my vertex over. So there. Well, my vertex is at 3 now. So my axis of symmetry is x equals 3. It's a vertical line that splits the graph in half, and it's always x equals, and then whatever the x value of the coordinate, the x coordinate of the vertex. X equals the x coordinate of the vertex. So if, let's say I move this over this way, well now, -4 would be the axis of symmetry. X equals -4. Okay, that's about it for quadratic functions. I'll see you tomorrow in class.